Alrighty guys, so today we're just going to spend quite a bit of time just going over some of these problems and just talking about how we make that normal distribution, the z-scores, and just do a bunch of problems like that. Okay. So you may want to ask the substitute to pause. Once you get that handout, you may want the substitute to pause some of the questions if you want to try them on your own first and then play it to see how it goes. So that's kind of where we're headed. So let's start off with the first of these just to kind of remind us of what's going on. So this one says the mathematics portion of the SAT has a mean score of 500 and a standard deviation of 100. So if we take this normal curve right here, right, we can then say, okay, our mean here is 500. So every time we go to the right, we're going to add our standard deviation, which is 100. So one standard deviation to the right would be 600, 2 would be 700, 3 would be 800. Okay. When we go to the left, we just subtract 100. So it would be 400 is one standard deviation to the left. 2 to the left is 300, and 3 to the left would be 200. Okay. So now each of these sections gives us a percent, right? Okay, 3 standard deviations on both sides, that covers 99.7% of the scores. So what is the interval is asking, what is this number to this number, because that's the 99.7%. So it would be 200 to 800 would be our interval. Okay, what percentage of SAT scores is greater than 650? Okay, well 650 is going to be right about here, right? So that has to do with that z-score. Okay, do you guys remember how to find the z-score? Let me pull it up real quick. So it's the data point minus the mean over the standard deviation. Then we have a chart that we can use, which you should be able to borrow one of my ones. Just make sure you leave those laminated ones here. Okay, so we'd go, our data point is 650. Okay, minus our mean, which was 500. Divided by our standard deviation, which is 100. So 650 minus 500 is 150. 150, divided by 100, it's 15 over 10, which as a decimal comes out to 1.5. Okay, so our z-score is 1.5. Well, what percentage does that mean? Okay, so for that you need, let me go to this table. Okay. So our score is 1.5. So this is how you read this table. You look, this is the negative, this is the positive. So, and I'll zoom in. So we pull up ours, okay, and the z-scores is giving us kind of this visual. We're finding this number right here was at 650. Okay, well what percent does that area cover? Okay, that's kind of what it's looking for. So 1.5 is where we're headed, and let me erase that now. So we look down the left column. Okay, now you're not going to go to 1 and then find a 0.5, because notice these are in the hundredths, not the tenths. Okay, so we need to find 1.5 as we go down. So zoom in a bit more. So 1.5 is right here. Okay, then what's after the 1.5? Well, it's just 1.5, right? It's 0. So if we look up here at these columns, see we've got the 0 there. So it'll be that first column. So 1.5 will be that first column. So it's at basically 93%. Okay, so 93%. Put that back now. So we go back here. So our z-score is, our percent is 93%. Okay, so what that means is right here, all these scores below it make up 93% of all the scores. Okay, so that's our answer right there, 93%. Now, what percentage of SAT scores is between 325 and 615? Okay, so we're going to do the same thing. We're going to find those two z-scores we're going to find that percent in between. Okay? So 615 is right about there, right? And then 325 is going to be about right there. So we want to know the area in between here, which means we basically find this percent, then we're going to subtract that percent from the whole, from this percent, and that's going to give us our answer. So once again, we set it up with the z-score idea. So I go 615 minus 500 divided by 100. Okay, 115 divided by 100, so it'll be 1.15, right? Yep. Okay, so that's one score we're going to have to look up. Then the other would be 325 minus 500 divided by 100. So 325 minus 500 is negative 175 divided by 100 is negative 1.75. Okay, so those are our two numbers we need to look at that chart for. Oh, right here. So we've got negative 1.75 and a positive 1.15. So let's do the positive first again. So now we've got 1.15. So we're going to look for 1.1 and then 0.05. 0.05 is that column right there. Okay, I know you probably can't see that. So let me zoom in. So we bring it down here to 1.1, so right there. And then we're going to go over until we get, that's 0.04. So we need to scoot it over to right there. So for that one, it would be basically 87%. Okay, you might put 87.5% if you round. That's close enough for me. Now, for the negative 1.75, we're doing the same thing, but this time we've got to get the negative version. Okay? So we grab our other one, or flip the paper over. Okay, now we're going to negative 1.75. So negative 1.7 first. So negative 1.7 is right here. And then we need to go to the 0.05. So that column right there. Okay, so the sixth column. So let's find 0.175. 1, 2, 3, 4, 5, 6. So it's 0.04. Okay, so that's 4%. Alright. So there we go. So negative 1.75 is the 4%, and 87 is the other one. Okay, so go back here to this first score. So we've got 4% right there. So this area right here is 4%. This whole area was 87%. So now we take the 87 minus 4. So this area in between, which is what it was asking for, is 83%. Alright? So, quite a bit of work for these. So we probably will not get very far along here. Okay, but let's keep going. So, next one. Okay, same idea. So, it's basically doing the same process. Okay, so 68%, remember, is the one standard deviation on either side. That was 68%. From negative 2 to 2, that one was 95%. And then like on the last one we said, from negative 3 to positive 3 standard deviations, that one is the 99.7%. Okay, so the first question says, what is the interval contains 68%? Well, we know it's from the negative 1 to 1, but what does that mean according to our ice cream? Okay, so we've got the mean of 16.5 right here, and then our standard deviation is 3.25. So for 16.5, we're going to add 3.25 once to get that one, which is 19.75. Add it again to get our second standard deviation, 23. Add it again. And that gives us 26.25 for our 3 standard deviations. Now, if we take it and subtract 3.25, we get our other standard deviations to the left. 13.25, 10, and 6.75. Okay? So now we look at our first one. It says, what percentage of pounds consumed is less than 10 pounds? Well, 10 pounds is 2 standard deviations away, right? So it would be this line, so it's just this area underneath, which is that, 2.35%. Now, what percentage is consumed between 5 pounds? So 5 pounds would be like right there. And 11 pounds would be right there, right? So we just want to know that area right there. So to do that, we do the z-score. So I'd go 5 minus 16.5 over 3.25, right? So we take our number, subtract the mean, divide by the standard deviation. Okay, just like that. If you haven't written that down, make sure you get that written down. Okay, so then we do that to get our 2 z-scores, and we're going to get our percents and subtract them. So we do the first one, and I get negative 3.54. Okay, I do the second one, and we get negative 1.69. Okay, now I'm just going to hurry and find their percents on my piece of paper. I've already showed you how to do it. You should be able to kind of check to see if you know how to do it, but I'm not going to take the time to go through it every time. And you probably notice there's a problem. We're basically not able to find the percent. Okay, so it's basically going to be like 0.02%. Okay, it's pretty much off our chart. Now for the other one, negative 1.69 is about 45.5%. Okay, so essentially what we're looking at is pretty close to 45.3%. Okay, that number is so small that it's really not, oh wait, not 45. It was, hold on, it was negative 1.6.045, so it would be 4.5% essentially. Okay, sorry about that. Got to pay attention to those decimals, which I didn't. So that's really, like 4.3%. Not very many people. Okay. Alrighty, so if we did this one, we'd do the same stuff. Okay. You'd take the same process. 95 would be, 2 standard deviations away. So you'd start at 79 and then add and subtract the 3.89. I'm not going to do this one because I think the 2 examples were probably good enough. And I want to save time so we can look at the other ones. But then you just find where 81 is, 73 and 77, find those percents. Alright. Now, you could do it with your ACT scores as well. And you could just work it out the same way. So, I'll show you just one example, kind of. Let's say the composite. Okay, so the mean was 20.7, standard deviation 5.1, so that would be 25.8, 30.9, and 36. Going backwards, 15.6, 10.5, and 5.4. So, those are the intervals where we'd say, so 68% of people will be between 15.6, 25.8, 95 between 10.5 and 30.9, and then 99.7 between 5.4 and 36. Okay? And then you could take a look at your own ACT score and figure out what percent you sit at. Okay? And that kind of gives you an idea. Now this data we're using is from 2012. So you could find, if you could find updated data, you could see that same percentile that they give you. That's how they figure out the percentile on your ACT report. So let's say you got a 28. So right about here. Okay, so we'd go 28 minus 20.7 over 5.1. That would give us our z-score. Which gives us 1.43. Okay, then we use that handy positive z-score chart, and so I go to 1.4 and then over to 0.03, so that's 92%, 0.92, so 90 percentile, meaning 92% of the people scored at or below. That fills up all this other area. That's what the z-score is talking about. It's the area under that curve. So if we, took all the people that took the ACT score in this year, they would all fit in this little area with you standing right here. Okay? Alright, so that's essentially what we're going to be doing, just the same process. Okay? Now, I've kind of given you this paper with graphs on it, and the way I was thinking about you kind of looking at it and using it would be that this would be like -3, -2, -1, the 0, 1, 2, and 3. So you draw your normal curve right there. And then what we're going to have to do is we're going to have to find the mean and the standard deviation. Okay, and I probably gave us way too many problems, so we're going to have to kind of just skip around on some. Okay, so let's actually do, I wanted to do, let's do the house one. Okay, so remember there's a process to this. Okay, so first off we need to find the mean, which they often write like that, or like this, and the standard deviation, which is written like that. Okay, so the way we find the mean, remember that process is like this. Okay, I'm going to find all the numbers for myself using the calculator with a pause, but remember, you first find the average. Okay, you take that average and subtract it from all of these numbers. Okay, then once you've got those new numbers, you square them and add them. So you square the numbers, add, and basically find the, let's say it this way, you find the average of the squared numbers. Then you take the square root of that, and that is your standard deviation. Okay? Alright, so just to take you through the process, here were all my numbers. Okay, I took their average and got this. Then, so that's all the average, then I subtracted these just like this. That gave me this set of numbers. Okay, I then took those numbers and squared them right there. Got the average of that. Okay, then my last thing was I took the square root of that to get my standard deviation. So those are the two numbers we need. Okay, so kind of screwing up my curve there. Just go like this. Okay, so my mean here was, and I just got rid of it, it was 214,366.67. Okay, so 214,366.67. Then my standard deviation was 11,182.13. Okay, so for my one standard, two standard deviations, three standard deviations away, you would just take those numbers and add them and subtract them to fill that out. Okay, so that's my mean. And then each one of these would be a standard deviation. Okay, and so I could fill out those with numbers. These numbers are pretty big, so I'm going to hold off on that. Okay, and that's where we start. Okay, then to find the z-score, right? And we could do the whole one standard deviation away. That's 68%, 2 is 95%, and then 99.7% is 3. And I could see all those intervals and those numbers. But now we do our z-score. So our z-score, we take our number, subtract our mean, divide it by our standard deviation. And that's going to tell us where ours lies in the scheme of all of these numbers. So if we were looking to see in an area, the house is priced at this much, is that going along with the prices of everywhere nearby? Because you don't want to pay too much for something. Okay, so we get negative 1.2847, so 1.28. So then we go to that slide, this. So negative 1.28. So we go down to negative 1.2. So right there. And then this was 0.09, 0.08. So we're right here. So 11%, basically, 11.3%. Okay, so what that tells us is our house is cheaper. There's only 11% of the houses that are cheaper than our house. Okay, that's essentially ours is, somewhere around here. This area under here is 11%. And that's what the percent on the z-score is. There's your z-score. There's a percent that's connected to it. Okay, so we can do that for each of the rest of these and kind of just see what's going on. Okay, except I've probably only got time to do one more, so let's pick one with smaller numbers. Man, I sure chose a lot with big numbers, didn't I? Okay, here we go. Let's do this one. Alright, I will, if I can, I'll see what I can do about those other ones. But here we go. So for the first step here is we need to make our curve, right? So our mean is right here. Alright, so my z-score would go something, maybe I'll make a better curve. That was a little better. Okay, so there's where our points of inflection are. 2 standard deviations, 3 standard deviations. Oh wait, so now I've got to work through this. So I'll pause it, work through it, and then have my information. Alright, so here's our data. So our mean is 1. We'll say just 95 to make it a little easier for us, 1.95. Okay, our standard deviation, once we subtracted them all, squared them, averaged, square rooted, we got 0.59 for our standard deviation. So we'll just say 0.59 to make it easier. So now we're going to add and subtract that 0.59 to 1.95 to see where we're going. So we end up with 1.36, 0.77, 0.18. Okay, going the other way. We end up with 2.54, 3.13, and 3.72. Okay, so let's say we've got one with a birth rate like here of 1.02. So that would be, somewhere in this range, right? Okay. So then we are going to find its z-score. Okay. So we go 1.02 minus 1.95 over 0.59. So 1.02 minus 1.95 divided by 0.59, we get, for our z-score, negative 1.58 when we round. Okay, now we're going to take that, negative 1.58, negative 1.5, and then the 8 so 0.06, so 6.5%. Okay, so that's our percentage for our z-score. Okay, now let's say I think the replacement percent for birth rate, to make sure that you replace all the people you have, is 2.1. Okay, so 2.1 would be somewhere right here, right? Well, what would that look like? Okay, so we'd go 2.1 minus 1.95 divided by 0.59. So we put this one in our calculator, and we get 0.25. So if I go back to that positive one, okay, so 0.25, so we'd go 0.2, so 0.2, and then that's 0.00, 01, 02, 03, 04, 05, so 59 point, so basically 60%. Okay, so that's quite a big difference, right? That means, just using this small piece of information, all these countries, 60% of them are below that replacement rate. Okay, so not a whole amount. Portugal, if this were true, I'm not sure if it is, would only be 6.5%, so they've got a pretty low birth rate kind of idea. Alright, take a second, or take a few minutes, try to do as many of these as possible. I will try to have just it set up so we just have the answer so you can kind of check your answers. Okay? Before you get going, don't do number 7, 8, and 9. This one's too similar to the mountain one. Okay? So and if we look at the mountain one, alright, so you take all these, find the average, the mean, that's the number you get. That's the one that goes in the middle of your graph. Okay? Then to find the standard deviation, we take that average, subtract it from each number, square each of those numbers, find the average of the new ones, take the square root of it, that gave us our standard deviation. So we added that standard deviation and subtracted to get those other numbers. So remember, between those two, that's one standard deviation away, that's 68%. Between two standard deviations away, that's 95%. And between three standard deviations, that was 99.7%. So pretty much 100%. Okay, now these numbers are just for this group. So we added a different mountain, and ours was a lot smaller. Notice how it's a lot smarter. So when you find a z-score, you get negative 9.5. That's off our chart. So that's like 0%. That means like it's so far down that it is highly unlikely, because when we look at all these mountains, they're so much taller. Okay? So there's that one. Don't worry about doing that one. Okay, let's take a look at this one now. Alrighty, so if we look at this one, so we've got our mean, 1,957.87, standard deviation, 1,254.52. Okay, so we put our mean in the middle, right? Then one standard deviation away, which is 68%, two standard deviations away, 95%, and 3. Okay, and there's all the intervals for the numbers of that. Now, if we wanted to find where does platinum, where does it sit in that boiling point? Okay, so we did it 3825. We took that minus the mean minus the standard deviation, got 0.77. Looked at our chart, that's basically 78%. Okay. Now we're almost out of time, so you're going to have to take a look at these. Just one thing to notice, sometimes the mean is smaller than the standard deviation. That's because look at the spread of numbers we have. Okay, so if you need to see that more, pause it. You end up with 95.7% for the z-score. For the hacky sack, you can see this right here. Okay, smaller numbers, easier to see. One standard deviation, 2, 3, z-score of 64.8%. So last one. So here's the last one, And I just realized on a couple of my z-scores on the last couple I got them wrong, so here you go.